Yeah, but I'm very excited to host this panel with a group of amazing robotics leaders. These folks that not only build robots, but deploy them out in the field. And that's super interesting and very rare to see. And my name is Justin. A little background on myself is I have a advisory firm called Almansor, but I also used to work in robotics and startups for construction. I've known some of these folks both from TechCrunch articles, but also from venture capital friends. But yeah, I think we'll keep it a little bit intimate, and I think what we'll do is just do an introduction of themselves, the company, and then we'll have some questions, and then we'll have some Q&A. But feel free to sprinkle in your questions throughout the period. We have some different topics we'll cover, as you'll see. And yeah, we'll just start off with some intros. If Gary, you want to start off with us. Name, company, a little bit about the company, stage, problem, and a fun question, and I'll go to your slide too. So, yeah.
Got it. And fun question would be for the audience, or?
Fun question is, what Olympic sport did you enjoy watching?
Oh, okay. All right. So, sounds good. My name is Gary. I'm based out of San Francisco with my company, Robotics. We're an early stage company. We have a team of 9 people and been working on this for 3 years. My own background has been in working on autonomous vehicles, previously at Waymo, and before that doing research at UC Berkeley. Sorry, what else was there?
Yeah, what was the problem? Tell
Yes.
us about the company.
So Raise, what we're doing is automating assembly tasks on construction sites, essentially installing things with nuts, bolts, and screws. Today, we primarily work with facade subcontractors as well as some concrete subcontractors. We see that a lot of the challenges that our customers face are primarily due to labor shortages. And in particular, this is work where they require very high precision, which means they need really skilled tradesmen, and they can't really find those anymore. And today, when they go out to site to do this work, they're staffing jobs as late as 1 month before project starts, which is an unsustainable future. And with our robot, what we can do is help increase productivity. So we can have 2 robots and 2 people do the same work as 6 people today. And we can guarantee consistent results while moving people out of harm's way. A lot of these jobs end up taking place in risky situations. For example, working at the edge of the building or being on your hands and knees or in trenches all day. And that's work that we don't want people to do anymore.
Do you want to go to the video?
Yeah. Oh, should I do a fun question? The Olympic sport?
Sure.
So I'm personally a climber, so I really enjoy watching climbing. That's something, yeah, I spend a lot of time going on YouTube watching highlights.
And then do you want me to play the video that you have too?
Yeah, that sounds great. Yeah, so here you can see some clips from a project we did over in Dallas. This was with DPR and Harman, GC, and a sub based out of the US. You can see here a robot is localized to a tow station on site, so it knows where it is and where to install components. We work directly with existing floor plans, so we don't require BIM data to do work to have the robot work on site, which is something our customers have really appreciated. With the robot, this is the first application we developed, installing these brackets at the edge of the building. As I mentioned before, this is one of those applications that puts people at risk of fall danger, and it also ends up greatly slowing down the work as a result because of that. The robot operates fully autonomously in this video, so none of this requires human intervention. It's able to install these brackets, do all of the fastening, and then torque them down to spec all autonomously. We use machine learning and AI in the manipulation part so that the robot can see what it's doing as well as perform the motions correctly, especially some of these motions which have very tight installation tolerances. Our robot also has a nice little, what we call a toolbox on board, so it can use a different variety of end effectors to be able to do the work. So it has some parallel grippers to be able to actually manipulate the components, a torque driver to torque nuts down spec. We can torque up to 80 foot-pounds. And we also have a printer on board to do layout after. This is something that our customers, have highlighted as a very nice feature to have, so they can then know where the brackets are installed and be able to install the panels in the right place. And then I'll just let this play out for a couple seconds. All right, and now you can see the printing. After the job is done, or actually during the job, what we can do is actually generate installation reports for our customers. So you'll see here, there's a little CSV that we give to our customers while the job's being done. This allows them to see deviations on the building from drawings in real time. That way they can start getting ahead of rework as soon as they're discovered, instead of having to wait to do the installs and discover in the process and have to fix a lot of stuff. And that's all I have to share.
Awesome. Thanks. Kevin, you want to?
Yeah. Hey everyone, Kevin Albert, co-founder and CEO of Canvas, also a company out of San Francisco. Canvas focuses on basically bringing automation to the construction site to help install materials on site. And so we focus on kind of the interior trades, where in exteriors we have a lot of heavy machinery like excavators, backhoes, cranes, things like that. But the interiors we do predominantly most of the work with hand tools at this point. And so we're targeting those trades. And our first market is drywall finishing. That's the step between hanging boards on the wall and when you paint them. And it's what we've found to be one of the most labor-intensive trades in construction, because workers have to keep coming back to the wall in 5 iterative steps to apply compound on the wall. Favorite Olympic sport that I watched was definitely ping pong. I was really rooting for the Swedes, but they got edged out in the end. But it was super exciting. And of course, robots also do ping pong, so it's hard not to love that. But yeah, to get a sense for the way it works, we actually use the accuracy of the robot to really reinvent the way the trade is done. So typically this takes 5 days of iterative application of joint compound to take a wall from a panelized system to a flat surface. The machine automatically scans the environment, so we don't need any BIM, any plans, anything at all. You can pull it in and go today. It identifies using AI all of the features and seams on the surface and plans out workspaces for the machine to do. The worker can select which workspaces they want, and then the machine goes and applies all of the compound in a precision layer in one shot. And so this is 4 days of application for a manual application getting done in 1 day. We let that dry for 1 drying cycle overnight, put a sanding head on the same machine, same process, and it sands it back to a final finish, fully vacuum capture, so no dust in your environment, completely clean, taking a lot of the burden off of the worker's body and allowing them to basically drive this machine. And then in real time, we capture all the data that's happening. So this not only helps coordinate projects, it gives us kind of deep insights on exactly what their workflows look like, so that we can basically give them insight and help them understand where they're losing efficiency, where they could be more efficient. And then finally, it allows us actually to do basically data-driven customer support and continuous training on systems. So our engineer or our tech support can be on a Zoom interface at a moment's notice for all of our customers. So that's basically how we've created a platform that now can bring heavy machinery into the interiors and bring automation to a lot of the trades that still haven't kind of gotten to that.
Awesome. Yeah, that's super exciting, especially with the data collection and feedback back to the reporting on site and how it's doing. So we'll have one more introduction, and then we'll start, going into some of the questions that cover different challenges and issues. So, Scott.
Hi, everybody. My name is Scott Fairley. I'm the founder and CEO of Optimotive. We're a Canadian robotics startup focused on the enablement of automation in what I like to describe as muddy, dusty, and otherwise unpredictable environments, like a lot of you guys find yourselves in. Primary bread and butter is construction. We built a data collection robot. Obviously, data being a hot topic that's been discussed a lot here today. Think of data as the new oil, and we're almost like the oil extraction rig, and how do we get that data out from the field? We built a mobile data collection robot named Iris. Maybe you've had a chance to check it out upstairs. It's a wheel-based platform, really targeting those heavy civil builds, think airports, military bases, and things of that nature. So obviously really expansive job sites. If you're trying to go out and build like a Tim Hortons franchise, for example, if there's any Canadians in the room, not all that big deal to go out and capture data on one of those sites. But when those sites start to scale in their size to the hundreds to thousands of acres, data capture becomes a real pain. So we built our little robot to be able to go out and automate that process for our customers. It's something from the Olympics. I was a huge fan of Rock'em Sock'em Robots as a kid. So obviously boxing was a fun one to watch for me.
Yeah, so I think with that, we did brainstorm some topics that we could talk about, but obviously if you have any questions, feel free to just raise your hand and ask them as well. Before getting started, I did have a question for the audience. Is just one is, who's coming from GC side? Raise your hand. And who's coming from the sub-specialty trade side? And then who's coming from BIM, VDC, that area? Yeah. What about like innovation teams within some of the contractors? Okay, what other industries? The same hand went up twice. So, software companies, private equity, investing,
Government.
Manufacturing.
Great, awesome.
Insurance.
Interesting. Yeah. So I guess it looks like we have a very wide variety here, a little bit outside of also construction. And I think one of the first questions before we dive into some of the other questions is, where do you, for all of you on the panel, where do you feel like we are on the whole robotic adoption curve within the industry? So as you all might know, you could be super early, you could be a little bit early adopter, you could be fast follower, even like mature. But kind of want to hear from you all from your experience with building, deploying, seeing the robot and the reaction, where you feel you're at. So, Kevin, start.
Sure. Is that a question about our company specifically, or where the industry is in general as far as
like kind of a broad swath?
Yeah.
Question generally. Yeah.
Yeah. I mean, honestly, I think what we found is that the industry is ready to adopt, and it's about actually a lot of the robotics technologies maturing to the point where we're delivering kind of the 3 keys for adoption for the industry. And I think a lot of the kind of muscle memory and how to adopt and how to, communicate internally in organizations is still developing. But like, we see most people leaning in more than leaning out. But I think it's more about all the robotics companies continuing to move into that adoption curve as opposed to necessarily the industry completely shifting to being ready to adopt robotics.
And yeah, I would add to that. I think even the last 2 years, I've personally seen a lot of subs that we work with start changing their minds about robotics and being a lot more active. And even some of the subcontractors we work with are now asking us how do they actually change their process to make it more efficient to use with a robot instead of us having to just work with the existing process. I think that's really exciting to see.
Yeah, I think so too. Like, we're definitely in the upswing. It has definitely not always been that case. Like, when we first started on our journey at Optimotive, like it was definitely the case that everybody was like, what the heck do we do with these robot things, kid? What are you trying to sell me? I remember having a conversation with a larger GC back in the day where they would say like, oh, like this looks like something I'd give to my grandkids to use. They didn't really understand the true utility of it. And I think the adoption of robotics platforms is becoming more and more aware as an industry in general. It's definitely getting easier than ever to get these types of things out to market. It's easier to build them, it's easier to deploy them, and the customers are starting to wake up to the true ROI of it, with it not just being essentially like a marketing gimmick or something. It's a true utility that they can extract value out of.
Yeah, it sounds like the excitement of robotics coming into this industry is there. It's kind of navigating all together as a team. Like, you're all on one page. How do we figure it out and get it out into the field?
For sure. And I think we're in that exciting phase too, where it's like the excitement gets your foot in the door, but then how do you convert that into long-term value? I think that's where we're starting to get to, is the excitement made sales for all of us, I hope, a whole lot easier. But that excitement and hype essentially needs to convert into the true utility. And I think that's the cycle that we're entering into now.
That's really helpful. That sets the backdrop for our challenge question, which was like, how do you envision the integration of robots with the existing construction flows today? And what challenges have you faced in building robots and getting it integrated with the traditional workflow? It kind of spoke a little bit to what you were starting to talk about, Gary, but like kind of expanding on that question a little bit more.
Yeah, so I think today, we really try to work with our customers instead of asking them to reinvent the process. I think that's very important because you don't really want to be spending months trying to redesign how people are doing work on site in order to get a robot on site. You kind of want to be able to drop it in, test it, improve it, and that's what we really try to do with our customers. Make sure that we're not requiring a lot of additional information from our customers to get the robot to work, and make sure that they're not, kind of having to rearrange the whole site for us to use our robot. So I think that's the easiest way to introduce robots, and I think that's also something that our customers have always consistently highlighted as a really major value proposition for us.
Yeah, no, I think one of the bigger challenges that we've come to understand is how the machine fits with the perception of the stakeholders on site. So an example is, and sometimes you can have our machine running where the worker's just standing there watching it. And someone will come by and say, get to work, and the guy's like, I'm running this thing. Like, and not only that, but like, personally, they've been taught years and years, if you're not moving, you're not getting stuff done. So they actually feel bad about, even though they're getting the production that they need to be getting. So we've actually seen things like that, as far as how do you make the workflow such that the perception is there, and they like the workflow that they're running through and things like that. And I think that's been one of the biggest challenges, because I think you can come in with the technology, you can hit all the metrics, but it doesn't necessarily have the holistic effect that you want. And so it's about addressing all the different stakeholders.
And yeah, like obviously in construction, you'll find that every single GC kind of has their own process flows and things like that. It's important that you do not interrupt that while still providing the value for it. We found on our side of things, like if you're showing up to a job site and everything's on fire, everything's a mess type of a thing, the last thing that they want is an innovation project showing up to their site and saying, hey, can we try this robot out here? And it's like, no, go away. I'm trying to solve a million different problems. So that seamless integration and trying to be as hands-off as possible and essentially require as little out of the customer as possible. So you don't necessarily want to go in there and say, here's a brand new software stack, here's a brand new hardware stack, here's an entirely new process, here's a new reporting structure. You want to essentially find a way to kind of slide in a way that they almost didn't notice it happened, though they're seeing the inherent benefits of it. Where yes, they can see the improvements of it, but it wasn't this like complete upheaval of everything that they're traditionally used to. And in the early days of startups, when you're trying to deploy like pilot systems and MVPs, it is definitely that. It is a huge challenge, and there's a lot of headache that goes with it. So it's just mission critical that you stay as focused on that as how do you make it the least burden to them to get the system to come up online, because obviously you're a stakeholder and you know I'm going to get this thing to be successful and I know they're going to like it. But it's not always going to be that way, especially in the construction culture. Like it's very much a culture shift, as Hamad was saying, towards innovation in these environments. So it's very, very different. So you want to be as seamless and as hands-off as possible.
Yeah, I want to give a little pitch that's like the counterpoint to that,
Sure.
to the folks here too, because one of the biggest challenges I see with robots is like we're hardware, it's not software.
Yep.
We have 2-year cycles, 1-year cycles when you get good at refreshing to a new platform. So we're on our 3rd generation. Mm-hmm. The reason we needed to wait till the 3rd generation to really hit all the needs of our customers is because we didn't get all the feedback and the context. We really needed to hit their pain points on the 2nd generation, and that cost us like 18 months.
Sure.
And so my pitch to the group here is, even though when we have wires hanging out of our stuff early on and you don't want us to disrupt your site, being engaged early and making sure that you're giving the feedback, helping us understand, and not me, but like the ones that are just starting up, what your biggest pain points are, so they can attack those early, so that even with their crappiest machine, they can get something that you like and get to that in their 2nd iteration, is a huge impact on how well this will integrate into the industry.
Yeah, and I think that was something that actually really helped us out when we started out. We had like a GC partner and a sub partner who were willing to take a bet on us, even though we only had a drawing on paper. And they're like, hey, can you get a robot on site in 2 months? We're like, we'll try, maybe give us 2.5. So I think having people in the industry who can kind of champion innovation like that, it really makes a big difference. It could be the difference between you getting a prototype tested and being able to raise money, or start going under.
100%. And in our story, it was Palmer was one of that customer for us. It was like they took that early bet on us when it was a very hacked together and literally duct taped together in some conditions robot, and it's kind of led us to where we are today. So those early champions are critical in the story.
I love the point that you guys talked about, was it's just not the manual work. It's not just about manual workflows that the robot is integrating with, but it's also the digital/technical stack that needs to be understood. And I think having some sort of templated audit to understand, are you using this reality capture software, are you using this project management software, and where does the data actually have to flow before you actually start to slap the robot on site and just start testing things. Now we got to kind of figure out where do the data go afterwards, is really great insight, because I think. And we kind of chatted a little bit about this upstairs with some of you guys. It's just some people don't use the same stack, not even on the same projects. So then you're kind of trying to figure out mid-flight, okay, should I integrate with this reality capture software and then put that on, or should I actually do this camera or this other reality capture software? And it differs by customer and project as well. So that's really awesome. Any questions from the audience about the challenges part? This is like a little bit of a section around that, but if any questions, feel free to ask.
Yeah, I have a question. I've seen lots of robots for construction so far. Is there any similarity between your different devices? And the reason I ask is because knowing how a lot of subcontractors operate on site, the machine breaks down, they have their guy that they call, they've got a service contract with. if it's a Caterpillar product, it may not be Caterpillar that's coming out to fix the machine, because all the machines basically use a lot of the same parts, so they can have a mechanic service that can come out and do that. Are there similarities enough between the different robots where there could be a robot guy that knows enough to get the thing running again? They all use Omron stuff. Like, so I'll just throw that in there.
Yeah, definitely. And that exists already for manufacturing. You kind of see that. And so what you're going to see in construction, you see all three of our robots are mobile. So mobile manipulation will have kind of that. And you have those in logistics centers, you have those in hospitals now, you have those in warehousing and manufacturing. So it probably isn't the Caterpillar value chain. It might be a different one unless they wanted to jump and expand their kind of tool set. But the way we look at starting it up is we do all that stuff to start and are very hands-on with it until we can get enough scale where we can bring out an outside partner to handle that operational support.
Agreed. Yeah, it's the same on our side of things. And as far as like the similarities from robot to robot, like it's all perception, it's all computes, electrical, and things of that nature. So there is going to be some like knowledge overlap there. As far as the exact parts, I can't speak to that specifically, but same with us. Like we're doing all that service contracting in-house with ourselves. Customer's got a problem on site. That's an us problem. It's not a them problem.
Yeah, just curious about how you guys are thinking about bringing the cost down on these things, because obviously they have to compete head to head with humans, and each, so I see 3 different robots up there. It's obviously not going to be just one robot. Maybe it will in the future, but like you're probably going to need multiple different versions to do drywall, to do studs, to do all these other things. Like in your guys' opinion, like how do you bring the cost down? What's the bottleneck for you guys? Like, what is the really expensive part of innovation? Is it certain parts of hardware? Like, it would be great to get these things where they're not hundreds of thousands of dollars and they're $30,000 kind of thing. Like, is there a world that
Yeah, I think about it 2 ways. I think about it as bringing BOM cost down, and it's the hardware. The robot arm on our robot costs $35,000. So I already can't make my robot for the price you quoted because the arm has blown that up. So it's bringing that hardware down, and that's coming down as we start to produce more units. That helps as we start to really streamline the manufacturing design and go to contract manufacturing. Those types of things helps. But the flip side of it, and I actually think this is the more powerful one, is really continuing to drive productivity up, and because cost to you is really a question of ROI, and so we do a leasing program where we charge kind of a monthly rate, and the productivity we create, the cost savings in labor offsets the monthly cost of the robot. So therefore, and as productivity goes up, that can drive profits for both contractors and us type of thing.
I'd say that's the key. If it's less than the salary of the people doing it and it's less headache, then clearly they're going to go that direction. But that's where that question is kind of coming from.
Yeah.
It's like talking about going head to head, it's going to compete with, the salary of a drywall makes no sense. The drywall is probably the same cost of robots, whereas right per year or 2 years or even 3 years, right? And so that's where I'm getting, because that's how I go and drive this stuff. I'd love to get all this stuff onto our job sites, but the question just becomes like, what's the ROI on this? And every time I get it doesn't work the way that it's beneficial to whoever's making that decision, right?
Yeah.
You guys lease the robots or you guys sell the robots to your customer?
So we lease. We do basically a monthly recurring lease.
Okay. I mean, it gotta be cheaper, like annualize the leases than the salary of the workers, right?
The lease costs less than the salary of the worker.
Yeah, you should. It's not like $80,000 a year to lease the robot.
Yeah, ours costs about 50% the salary of a worker, and we create about 1.5x production. So the math gets pretty easy.
Yeah, we're in the same boat. We operate on a leasing model. I think robot as a service is going to be a continuing trend that you're going to see more and more of. Like if you look at like a Boston Dynamics, for example, they're very much a sales model, but like I like to say that we're the experts in robotics. Our construction customers are not necessarily. All they care about at the end of the day is the task is done the fastest, the cheapest, and the most effectively to the degree that they see fit. So in our context, like we did an ROI stat for our customer on a solar farm, and it ended up being that our robot cost $8 an hour when it was ripping around doing its data collection tasks specifically for solar panel inspections. So I would challenge you to go find somebody to do those tasks for $8 an hour, right? So that's where it makes sense, right? But then there's obviously the back end cost of that, which as he alluded alluded to the BOM cost, like what does it cost us to build a robot? If it's extremely expensive and you can only charge so much to it, we are losing it. Essentially, you're subsidizing it using venture dollars, right? So that's something that we have to be proactive on, ensuring that these robots are low cost. I always like to say use them, abuse them, scale them, and make it so that they're a low cost to the point where they can get the task done reliably and effectively for hopefully years on end, but while simultaneously not costing us an arm and a leg to be able to go and produce one.
Sorry, shoot.
Yeah, I have a couple of questions. The first one is, we've been hearing about robotics for a while, and sometimes it feels like we want the robot to do the whole task. And then we break them and it takes forever to develop them. How about, I guess, what are your thoughts or conversations with GCs where the robot is just an assistant? Kind of like, we're talking about AI being an assistant on the job site. How can robots be equipped to just do very, very specific niche things? I'm thinking as an example, like the Hilton Jailbot, for example, it just does holes to alleviate like working, I guess, on ceilings. And then the second question that I have, which is a little bit of a parallel, how do you see robots and productization of construction coming together? So like, are there things that we can just teach the robot in a warehouse and then also teach it to complete on a job site, for example?
I guess take a stab at these. Yeah, for the first question, I think that all of the robots that I personally see, at least for construction work, are performing niche tasks today. And I think everybody's on the same page that it's not designed to, replace a person. It is supposed to be a tool for existing tradespeople to use. That's, I think, the best way to get a robot on site. I think that's where you see the best returns as well on, productivity versus costs. And then the second question, as far as like training robots in a warehouse to get them to work on site, we actually do that, and we've seen pretty good results with that. So I think that's definitely possible. I think that's also a very interesting way of developing a robot, basically being able to kind of move that like challenging work into like a more controlled environment, like have somebody work with the robot to train it and then get that to deploy on site. But now the person isn't kind of doing that challenging work on site, but they're helping the robot learn it in a more safe environment.
Yeah.
So I'm a software that needs 360 images to work. I don't give a shit where the 360.
We're your people then, okay?
But it is a pain for every GC,
Yep.
right? And so I'm fascinated by this robotics thing, and they're coming out rapid fire,
Yeah.
right, of these robotic solutions, which is great. But like, those robots can't be all things to all people. Like, they can't open doors or like scan key cards once doors start getting closed in. So how do you bridge that gap of like, do you go in and say, we can only get you to 60 or 70% of the project and then you've got to do it manually from there? Is that essentially what has to happen?
Sure, yeah, it's a concern. So to give you context of where we specifically operate on our side of things, we're mostly doing exterior heavy civil builds. So think solar farms, airports, military bases, battery plants, data centers, that kind of stuff. So the doors question isn't really relevant. Obviously, wheel-based platform stairs the scariest thing you could possibly look at. So it is definitely a grander problem. I think to speak more generally from an industry perspective, like you'll see offerings from like Boston Dynamics Spot, for example, which will have an arm on it that opens up the door and does it that way. Yeah, it's an expensive package. Don't get me wrong. You'll probably throw up when you see the quote, but it's one way to do it, right? So it's definitely something that needs to be solved in the sense that, yeah, there is still 100% gaps. I'll be the first to say it. Like there's definitely gaps where it's like there's just not going to be the right fit for it. And it's also important that we don't run in kind of tailoring off the former question, live in a mindset where we expect the robots to do absolutely everything and just gets it all done all together kind of a thing. So we see like highly task specific robots do very highly specific things and generate really good ROI statistics at that limited number of things. And that's really the state of the industry now. It's not very generalist and broad to the point where I could say, yeah, my robot can run for hundreds of kilometers on a massive solar farm, but by the way, it can open up that door for you and do an interior. So there is definitely some gaps in the market that still exist that I believe are technical problems that can and will be solved at some point.
Just a quick follow-up to that.
Sure.
I mean, in that case, are the customers kind of saying to you like, well, come back to me when you can do all the things to all the people, or do you have enough customers now who are like, okay, we're in?
Yeah, we're definitely highly specific in the types of job sites that we entertain. Like we're very eyes wide open with the customer, say like, nope, that's not it for us. Like that one's just not going to work. When working, so primarily we're with very heavy, like large GCs, Elliston, Palmerloo, Kiewitz, those types of multi-billion-dollar players. So that usually they will have sites that are of relevance to us, as mentioned, like the solar farms and things of that nature. So it's important from our mindset to inform them right out of the gate of the limitations of what we're offering. You don't want to sell them the moon and say it can do absolutely everything for you and it's all going to be sunshine and rainbows. You kind of give them that preconception of this is exactly what we're here to do. This is exactly what we're good at doing. And if they want to put us in an environment that we're unsure of, we say this is an experiment. This is a test. We're not entirely sure just yet of how this is going to play out.
There are some also general robots that are trying to do general reality capture, more on vertical builds, and those have a lot of challenges. It's kind of briefly alluding to them that we could definitely discuss offline if you want. It's been like a year. I'll go for you, and then Zach, and then
So since you guys are like a lease model, you're the service provider.
Yeah.
Do you guys come up with your own JSAs and safety protocols that you give to the GC? Like, we're not putting this robot on slab edge until you provide blah, 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 whatever? Or are they telling you what your safety protocols are going to be?
Generally, oh yeah, you want to go?
Yeah, I think like what we have is a set of best practices that we start with, like a template for like a GSA, and then we go every time we meet with a new GC we're working with, we work with their safety team to make any modifications they may request. But in general, it's been very straightforward. Just one meeting with the safety team that usually clears everything up.
And we've experienced the same. We have a stock JSA that almost works on every single project, and maybe we're a little we're closed in, so maybe we're caged a little bit. So
yeah, we're definitely in the same boat. Like we have a pretty standardized practice for it, and we will always love to do site walks of sites before we deploy because every single construction site's different. Every single one's gonna have its own risks and things of that nature. So walking through with the boots on the ground people to ensure that if there's any risk that maybe head office might not have been thinking of, that we can definitively see it and take it into consideration and bring it back to our teams to ensure that we're operating in the safest and most controlled manner possible.
And then you in the front after.
I think one pushback I get a lot trying to, I guess, bring the idea for robotics into the workplace is that it's always evolving. That you buy a robot today, and in a year or so it's outdated, or innovation is great.
Yeah.
How are you guys, I guess, as an industry, kind of curbing that issue?
So I think that's inherently solved by robot as a service. So this is the exciting thing about what we get to work on. At the end of the day, when a construction site is complete, that robot comes home to us. Under the robot as a service business model, that is an opportunity for us to upgrade, repair, and send the robot back out as the best possible spec. If I were selling you a robot, just like if I were trying to sell you a car, if you look at a early Tesla Model S versus the brand new Model S, they're drastically different, right? So being under that service-based business model, it allows us to continuously iterate, continuously make the robot better and better and better. So I know at the end of the day, once that robot is leaving our warehouse and going to that customer site, is the best possible robot at that time that we could build. So it inherently bakes in its own kind of upgrade plan per se. So there isn't this obsolescence in a year plus at the end of the day once the robot's ready.
You think of it as like hiring another sub for that particular work, and so that robotic company is now kind of the subcontract provider for that work.
Yeah, the other opportunity there is we don't actually bring our robots home. And so we have over-the-air updates. And so all robots in the fleet get all the latest software. All the images being taken by all of the robots across the entire fleet are fed into the same kind of data set and kind of AI training. So all the robots inherit that naturally. And so therefore all of our customers always have kind of the latest and best, regardless of when they bought the robot.
Yeah, I think one thing is like, I think with robots in construction, it's like you're not treating your customers like, somebody buying an iPhone, where it's like you just get an iPhone, they own it for 2 years, and you try to get them to buy a new one. It's like we really want to partner with our customers, make sure we're building stuff that works for them and listening to your feedback on an ongoing basis.
When it comes to the work side, let's say your robot is doing the drywall, like how does it work with the other trades? Let's say there's another, I don't know, they're doing the bathroom or whatever, or like the curtain wall, and they need to walk through the space. So how do you have your robot work with that?
Yeah, so there's two parts to that answer. The first one is we've specifically designed our system to be a worker-operated machine. So it's not like you've put a robot in a room and you go off and like do something like far across the building. Usually the way our system runs is one worker is running two machines. They're in relatively close proximity. They're going back. They're understanding what the other trades are doing. They're directing flow on site and handling the dynamic nature. And we felt that was really important, and that's proven to be an important piece of the puzzle. And then the second one is like the robot has LiDAR that has a full light curtain on it, and so basically that's a sensor array that says like if anybody's within the space, if there's a ladder within the space, it just stops. So unlike an autonomous vehicle driving down the highway, if that just stopped, that would be a disaster for us. If there's something afoot in front of the robot, it stops and notifies the worker who's nearby operating it that something's happened. So so there's, ours is a slow moving machine that no one's ever going to be scared that it's coming at them too quickly.
Okay. So in terms of cost, it's like you still need a worker and two robots instead of 3 workers, and then you cut down the timing. You can do something like maybe 1, 2 or 3.
Yeah, basically, we can do more square footage of production than the worker would be able to do with the traditional tools they use today. They just have a better tool. And then the other big one for us is shortening the schedule time of the project. So kind of trying to deliver that value, not just to the subcontractor who's finally in labor, but also to the GC, to the owner, so that projects can be completed more quickly, less volatility, all that stuff.
Okay, thank you.
Yeah.
Have you guys quantified the safety benefits of this, or like from an ergonomic side, especially for Canvas? Like,
Yeah.
there's a lot of safety benefits for.
That's a good one. Has anybody actually quantified that? Otherwise, I'll take a shot at it.
You go first.
Yeah. So no, we haven't. It's really hard to quantify the ROI of safety. It actually goes to the ROI question of the cost of the robot too. Right now, we don't see many people giving us much value for schedule savings, for safety, for attracting labor or being able to train new people. So our best performer was not a drywaller by trade. She was basically a laborer on the site, and now she's producing more than most of the drywallers, so attracting new talent to the industry. But we don't tend to get a lot of credit for that yet, and we're looking for ways to. On the safety side, usually the way it comes out is, for example, a data center we were doing was running 612s for a week, and by bringing the robots on, we were able to drop them down to 610s, as well as the workers said that they felt way less drained and strained at the end of the day and felt like it was much easier to do the work. So we get until we can get kind of like injury reports and differences and stuff like that, I'm not sure how to quantify it. So if folks have ideas, insurance in the room, would love to hear your thoughts. But I think there's a lot of value that's harder for us to bring out, but is there.
I feel like you have to do comps on the loss history of that particular work on
Yeah.
the building versus the time periods. It's like as apples as you get.
Yeah.
It's just some like ergonomics side of it too.
It's huge because the statistics in drywall is 1 out of every 4 drywallers ends their career with musculoskeletal disorder. Usually it's a rotator cuff or a back injury.
Yeah. So for example, GPT-3 ended up killing a lot of AI startups because instead of having these niche AI models, a single prompt could have it do the same thing. We know companies are working on these, generally efficient humanoid robots, for example, where a robot could just be trained to do any job. So as companies in this space, how would you deal with that threat?
Yeah, I think with the humanoid robots, I would say humanoid robots work in areas where that have been designed for humans to operate in, but that's not a construction site. Like a construction site has not been designed for a person to work in. So it'll be really hard to get a general humanoid robot to do a lot of the work in construction very safely. You don't really want to see a person hanging out the building, but why would you want to see a robot hanging halfway off the building to do work? So I think that's one big thing as far as if you take a look at general purpose form factors. I think that's also is the reason why you won't see a larger player come in being able to kind of obliterate smaller startups. It's because there's hardware. There's a much more defensible physical component to robotics products that software just simply doesn't have. It takes a lot of time, like Kevin was saying, it takes a lot of time to build a new iteration of a product, and that's all time that ends up getting baked into the defensibility of the robot.
Yeah, the other side of it is I think there's a lot of misunderstanding of how well AI really ports to something like robotics. There's 2 sides of it. One is the safety side of it. So a general purpose AI to do all of it has to be encapsulated inside kind of a safety layer that makes sure it can be in a bounding box and work properly, and making sure those two things work together. Like your safety layer is now not trimming the functionality of the AI system running it is a critical component. So that's kind of hard to develop in a vacuum. The second piece is the general robotics AI is so much bigger than ChatGPT. Like that's a 50,000 token degree of freedom space that if you're talking about the language models, and those are trillions, right, of nodes in their AI model. If you're talking about the degrees of freedom between just these three applications, it's magnitudes order bigger than that. So I think they're going to develop really fundamental things. And then the third piece that we're going to be able to use and leverage, but I don't see them being able to just make this general purpose AI that can handle his application mind. You're going to get special purpose foundation models for different applications. And then the third piece is the data set. Whoever has the data set makes the foundation model, and you can't get a construction data set without doing the work. Like you can't know what the historical material removal rate is from a sander being applied at this pressure without going and doing that a bunch of time. You can't see every single site and all the different lightings at that condition of the project without doing it. So it's the people who are doing the work that are going to develop those data sets and create the foundation models.
And I also think in the debate of like humanoid v like the robots that we build, like there's a reason why as humans we went out and built tools to be able to go and do the things that we do. Like if you're a humanoid structure, you're inherently flawed in certain aspects of what you're going to be able to do. So to that, I'm more of the mindset that we're going to see hyper-specific, task-specific robots that are drastically faster than any humanoid structure could go out and perform that task. Will we have humanoid robots in a construction setting? I would say so. I think it's a matter of time. How useful they will be in the early stages is unknown. But there's always going to be those task-specific robots that can assist in the humanoid structure, whether it's a human or a robot, to be able to go out and perform those tasks drastically faster. So I'm not too worried about it on our side of things.
Yeah, I really wanted to jump in on this one because I was actually part of a startup that's leading kind of the frontier in like a general purpose model for general robots in any environment. And so I think while that marketing is really great, I think the practical reality of where we're like gonna be is we're still light years, like really far from it. Primarily because of a few things, but if I were to summarize it, your environment is fundamentally different and unpredictable. So while you're in a very predictable environment here, both geometrically and semantically around how a robot could walk around, the same environment is not going to be that thing in a construction environment. So that's one. The other one is the speed of it. So the ability for a single purpose robot to be able to do, drilling these holes faster than the general purpose robot who's been trained to both navigate and pick up this and do all these different things has to account for much more computing horsepower, which would then slow down a lot of the work. And the third thing is accuracy. So I think with construction, what I've learned is no one's really going to settle for like 90% accurate. Like these single purpose robots have been like trained to do that one task like 100% accurate time and time again, versus general robots may actually miss the mark, five out of 100 times. So I think those kind of factors compound actually makes it very difficult to penetrate like the construction market in general, which is why you probably don't see a lot of those general purpose robots in construction, but more in manufacturing, more in warehouses, because they're very clean, very structured, and predictable. So I think, yeah, we are at time actually. So maybe we have one more question. You want to say that? Or no? Okay, we're good.
I was saying 5. You can take 5 minutes if you want.
We hit on a lot of the questions that we actually had kind of planned for the session, which was around challenges in the general industry with robots, the adoption challenges, as well as the innovation cycle. Safety reliability was touched on, which was a great topic of discussion, and pricing and value in terms of the ROI, the pricing model, the service model. So we did get a hit on all of these, even though I talked maybe like 5% of the time, which is great. But I really appreciate everyone's questions, and with that, we'll want to thank everyone for their time. They provide such amazing insights for their experiences. So thank you.